Hello guys, in today's video we'll talk about current sensing transformer. Okay, so for what purpose we can use a current sensing transformer in electronics? In AC, we know that an AC current induces or makes a changing magnetic field, which, when goes through an inductor, induces a AC voltage in it. So if we have not big amount of primary turns and very high turn ratio on the other side, we can use it as a voltage bump up transformer, but there is not a huge voltage across these windings. So the voltage that is basically here is just a voltage drop of the wire that is here. And of course it induces some current in the secondary. So we can just, the output voltage on the output of the transformer is proportional to the current that flows through the input. So this is a transformer that we'll use today in order to measure a short current of this transformer, and we will compare the result of a shunt resistor and a current sensing transformer like this one, and those are the parameters of the transformer that we'll be using today. And it truly doesn't output 650 milliamps. Maybe it's nominal power, but it can output much more, and we'll see. This is the shunt that we'll use today. I have written here ammetered AC/DC because there was a analog movement connected in here, voltmeter movement. But here we have, just as you can see, 10 watt 0.1 ohm resistors connected in series, and we just have 1 ohm here, so 1 volt drop, 1 amp through. So that's a simple thing. So right now I will connect the circuit and we'll measure some stuff. Okay, so here's the whole circuit. You have the transformer connected to the mains through this cable. Then it goes out here, goes through the primary winding of the current sensing transformer. On the secondary we have the first channel of this second channel of the scope, which is yellow. Then it goes through the shunt resistor, across which we are measuring voltage with channel 1 of the scope, so the blue channel. Then it goes through to the green wire, and I will be touching here with a green wire at this point. You can see that there are sparks because it's a pretty high current. It's like 1 amp and it's AC. So I think you can see, I can see in pairs and arcs. So let's get to the scope. Here we have scope, and let's right now measure the thing, stop it because we don't want wires to start melting, hit measure button, and as you can see, the yellow channel is the output of my current sensing transformer. So as you can see, it's a bit demodulated or disrupted because basically the magnetization curve of a ferrite core is not linear. So there is some stuff happening there, but voltage across the shunt is a true sine wave, and we can see that the RMS voltage on the shunt is 3.08 amps, and then we have the voltage on the transformer secondary, which is RMS 32.66 millivolts. If I'm sure we can, 32.66 here. So let's right now do some calculations and explanation how this whole circuit looks like on the schematic. Okay, so the first time I was measuring, those were my measurements. So here we have 230 volts coming into the transformer, then we have output of the transformer. Then it goes through 3 windings of the primary of current sensing transformer. Then it goes through 1 ohm shunt here and gets back to the transformer. Here we have a first voltage measured across these 2 points. So it's a secondary winding of current sensing transformer, and then here we have voltage across 1 ohm load. And when I did it the first time, the measurements were kind of like that. So V1 is equal to 90.28 millivolts, which is pretty much 0.09029 volts. And here you have 8 volts, which is 8 volts. And then we calculate the ratio of our transformer, so how output input voltage is decreased other side around. What is the relationship basically before this and this? So what is the relationship between real current here, and which is the voltage across load, and the voltage on the secondary here? So the relationship is that the current is decreased / the voltage, the representation of it, is decreased 88.6 times. And then I was measuring some other current, and this was the voltage that I got, multiplied by this, and it equals this. So it's a very simple measurement. You don't need to cut wires, and you don't need to tap into your high voltage circuit, and you can easily measure the current. And the current of the appliance that I was measuring at the time, which is the same transformer, which is this guy, I was measuring this, how much current it draws from mains when it's shorted on the output. And the current shown by shunt was like 1.338 or something like that, and the true current with this ratio here calculated was 1.298. So it's pretty close. It's like 10% tolerancy, so it's not precise measurement. I think it would be much more precise if I would count the number of turns on the secondary, but it's basically just a toroidal core transformer, 3 windings, primary, and very, very big amount of windings on the secondary. And this is how you can simply do it. So that was a short video, but I think it's a good hack to measure current in your AC circuits. Very simple way of doing it. You can even make a digital circuit for it in order to show the current in amps on the screen of your amp meter. So hope you learned something today, and see you next time.